Okay, so I'll be talking about the JSON version 5 format, and I'm sure some of you are familiar with version 4, but I'll plan on keeping this talk relevant to those who are new to the JSON altogether. And so, as you all know, CVE list contains a list of CVE IDs and a list of and each CVE ID has a record associated with it with relevant information that helps identify the vulnerability. For a long time, we only had the CVE ID description and some links as part of the record. And the descriptions, as Lisa showed the evolution of the program, the descriptions went through a lot of review and vetting to make sure the quality of those descriptions are good and accurate. But as we enter a new era of automation where CNAs are able to submit these entries into the database directly, um, we need to make sure that there is some minimal information that is needed to identify the vulnerability that is going in there. So the quality of the records is maintained at a minimum level. So what's in a CVE record? So if you look at the ID itself, it doesn't contain much information. Maybe something about the year the CVE was reserved. So the information associated with the ID all goes into the CVE record. So this may contain information like what is the weakness, what is the product that is affected, which versions, if there are any other identifiers associated with it. Some of the CVE descriptions may also go into details such as the affected components or program files or program functions. And so far, they have been mostly provided through the description. And the CVE record format aims to help laying this information out in a structured format, so it is available for automation, for validation, and so on. And so, at the minimum, a CVE record requires you to provide the CNA who is associated with the ID, some public reference that attests to the vulnerability, and some information about what's affected by the vulnerability. Additionally, things like dates, the issue published or updated, or people associated with one discovering or helping with the vulnerability, CVSS scores, or any other way of characterizing the vulnerability could also be considered information that's helpful in identifying the vulnerability. Apart from it, you can also have descriptions and translations of the description, or other useful information that could go along with it that can also go into a CVE record. The program chose JSON as a data exchange format because JSON is easy for humans to understand. You can take a look at the format in the raw form, though I would not advise you to hand edit JSON. It's easy for tools to generate and parse, and is kind of native to some of the architecture behind AWS, that is behind the automation working group infrastructure. And so the record itself is stored, transmitted in JSON format. One advantage is that it gives us an easy way to declare exactly the specifications in stricter terms on what type of data we are expecting in different fields, what length and formats, and so on. So it's easier to automatically check for quality errors in the JSON submitted records. So if we go to the CVE record itself, you have two types of records based on the state of the CVE. So you have a record type based on if it's a published CVE entry. You have one structure, data structure, to store a published entry. and you have a much simpler entry if you have a rejected CVE entry. In this talk, we'll mainly focus on the published entry because that's where most of your CVE entries will be submitted with. So think of this as a CVE record as like a form that you're filling on paper, and sometimes you see this place called for official use only. And so this is where the CVE metadata is stored. These are automatically updated by the services. These are not editable by the CNA, but these are but they will be present in a CVE record. And so this helps the metadata that helps some bookkeeping aspects of CVE record. So it can contain the ID, the CNA associated with the ID, date it was updated or reserved, date published, and the state. And so these are used for validating your submissions in the API, and they're used for and in where applicable, they'll be automatically updated by the automation from the API. The next major portion in the CVE JSON structure is the CNA container, which is the main area where you would be providing your information. And for those who want to maybe follow the mind map, so the mind map is a live interactive thing that's available. I'll paste a link to this, so you can navigate the structure of the format. And so the main area that you would be focusing on as a CNA, providing details about your CVE assignment, they go into this CNA structure. And so this has information about the CNA organization itself, date you assigned the CVE, date the CVE became public, the title of the CVE, if you want to provide us a shorter description for your CVE entry. And it contains things like the longer description of the vulnerability as a structured format for listing affected versions. We'll go into details into this later. And references and any other information that could be associated with the vulnerability and would help your consumers associate or identify the CVE. So on the mind map, the fields that you see as bold are required fields. Everything else is optional. So the program, so at the bare minimum, so if we had a discussion about before, if you want to start with some simple examples of the JSON, if you go to the CVE schema repo, you have two examples. One is a basic example, which gives you kind of the bare minimum JSON structure you need to have in an entry. And there's an advanced example which contains more example fields and type of data that goes into them. Okay, so similar to the CNA, so all the information you provide is stored in the CNA entry. And we talked about this concept of authorized data providers, where other authorized participants in the program can enrich or add, contribute information to the CVE record. That information goes under a structure called ADP, and so this ensures that they don't touch the data that you have provided as part of your entry submission. So if somebody adds a new URL, they're not adding the URL to your data. And the program mentions program ensures that the API services ensure that the proper permissions are checked to make sure only authorized people can touch relevant parts of the JSON record. Okay, so the main required part in a CVE entry is the description. So a new feature that's added with JSON 5 is that you can also have rich text representation of the description. And so one example is both rich text, and you can also have multiple language versions of the description. So this is an example where you have one description, but in two different languages. So this is one way to encode, not the one way, this is the way to encode multiple translations of your CVE record description. You would have a tag to indicate the language, and a text field there where you would provide the CVE description. I do not think currently the website renders other language entries, but in future, when you go to CVE, visit the CVE website and you see the description, you would see alternately the available language translations of this description in in the future. And as I said, a new feature in the CVE record is when you are providing descriptions, you're no longer limited to just being plain text description. You can include rich text representations of the description too, or maybe include small diagrams as kind of attachments to your CVE. So this is to take, especially help with the formatting of the CVE entry text. It sometimes it can be limiting if you are only limited to the plain text without line breaks or paragraph or little formatting. This this structure is kind of similar to how email includes both plain text email and HTML email. So you have the expectation is that you have alternate representation of the same information in the supporting media field associated with the description. Okay, we'll come to another important section of the CVE record format. This is where you are recording affected products or affected things that have the vulnerability. And this is critical to identifying a vulnerability, is identifying where exactly the vulnerability is. And so there is a list called affected, and each of that thing can contain an entry for a vendor and product. The product could also be identified either as a package name with a collection URL, where collection URL represents the base URL for a packaging ecosystem. And then you can identify not only the vendor and the product, but you can also identify the affected modules within the product or affected program files or program routines. Program files would be the source code file name associated with the vulnerability and the function names that have the vulnerability. You can also identify platforms that are affected by the vulnerability. So, for example, if you have a vulnerability that's only exploitable on, say, x86 platform, but not on ARM or something else, you can encode that information here to narrow down where exactly the issue is. We'll go into more details and examples on how to encode these. Once you have identified a product, you can also identify versions that are affected within that product. And so if we drill down to versions, a version object contains a version, status of the version, is it affected or not affected? And it has some fields to help you encode ranges of versions. So at the minimum, you just need version, but if you have a range of versions that are affected, you can encode them as well. And there are some features that help you to factor in things like patches that usually don't lend themselves as like sequential versions. Those could be encoded as well. So we'll go into more details and tips on how to encode versions in your JSON record format. So let's take a very simplistic example. Let's say you have a software that has version 1, 2, 3, 4, 5, 6 to 8, and only version 5 is affected. And so the simplest way you can encode it is that in the affected field, you have one entry for versions and say version 5, and you indicate status is affected. And then you have what's called a default status field. That's more like the default clause in a case statement, where if there is no rule matching any of the above, the default status should be considered unaffected. So what this encoding indicates is that you have version 5, that's the only version that's affected. Everything else is unaffected. And if you are doing it in the tool like Vulnogram, you would enter these three fields to encode this product. You would say affected, you would state the version that's affected, and you would say default status for anything else as not affected. Okay, we'll make it a little more complex example. It's probably most common is you have a vulnerability that has been there since the beginning of your product, and it got fixed in version 6, but everything before version 6 is affected by the vulnerability. So you would start with, so this is an example where you're encoding a range. So you can also go list all the versions one by one entry per version field. But you wanted to make it compact, you can encode it as a range, and you start with the version field is then used to indicate the start of the range, and then you have another field less than that indicates the version that doesn't have the vulnerability. So everything less than 6, starting from 1, everything less than 6 has a status affected. And the version type is a new field in JSON 5 that indicates what kind of versioning scheme you're using. You can use something like if you're using semantic versioning, you can say version type is semantic versioning. So this is to help any tools or consumers that are parsing this information to make sense of the encoded information. And the default status for everything else remains unaffected. So in a tool, you would enter as a range from 1 less than 6 is affected, everything else is unaffected. Now you also have just like less than, you also have another field called less than equal. That's when you want, maybe instead of 6, you want to use 5, and you say you would put 5 here in version less than equal, and it would mean the same. So there are multiple ways you can use this structure to encode your information, and it's really up to you on how you want to use it. We'll take another example where you have a set of versions that are affected, but it's a bug that was introduced later and fixed in another subsequent version. So you would start, your starting version there is 51, and yeah, this is an example. So it should be less than equal 53. This is the way you would encode it. So you would start with version 51. Anything less than 54 is affected. And if you are not sure about the initial version that was affected, or if you think it's from day one, but you're not really sure, this is like a 20-year-old software program, you really do not know what is the initial version that was affected. The JSON format defines 0 as a special number, which indicates start of any range. So if you have 0, it means like from day one, the most earliest possible version that the software ever had, that's indicated as a 0. So you would say, in this case, you would say from 0, any version less than 54 is affected. Okay, we'll take another example where it's just most common, where you have different branches of your software, and each branch is affected slightly differently. And so what you're seeing here is two branches of your software. Branch one, software version one, as major versions 1.1, 1.2, 1.3, and so on. You have another branch of your software 2.1, 2.2, 2.3, and so on. And so the ones that are red boxes are the software that is affected by the vulnerability. Everything else is unaffected. You would essentially have two entries in your versions array. One entry for this range in the top, another entry for this range in the top. And of course, you can enumerate all of them and just have one entry per each affected version of the software. You want to use the ranges, you can use them as starting from 1.7 to 1.8 and 2.4 less than 2.7. And everything else is considered unaffected. And now we are seeing another example where you have a piece of software, but it uses patches instead of versioning or sequential versioning. And so what you have is a piece of software, and you can have patch 1, patch 2, or patch 3, and there's a vulnerability in that version and vulnerability in patch 1 or patch 2 too. But when you apply patch 3, the vulnerability goes away. And so you would identify that software as software version 1 is affected, and it changes, the status changes at patch 3, and it becomes unaffected. And default status unaffected is for any other version that's not mentioned here. You can, if you're not sure about other versions, you can also say undefined, not defined for default status, which means it's not clear on what the other versions are about. But a thing like patch, you could use this status change entry and say patch. You start with version 7 that is affected, and the status changes at patch 3, and it affects and it becomes not affected. I have there's one more example is when you have software versions, but the way the vulnerability manifests depends on the platform it's running on. So it could be, you may have software that is running for Windows or Mac or Linux, or just different hardware that you make. And so let's say there is a piece of software that is running on Model T and also Model Q. On Model T, it's affected from version 1 to version 5, but on Model Q, it doesn't have the vulnerability at all. So if you have to identify this vulnerability, you would say affected platforms, you would have an array that includes Model T, and then you include the versions. And so this becomes like an AND operation. So it has to be these versions, and on Model T, then you're affected. Everything else is unaffected. You can also make it more affirmative and say you can include an entry for Model Q as well, and say default status unaffected, and all the versions are unaffected too. In the JSON format, we have another special meaning for star. This is more treated like infinity. It's like everything, the largest possible version that you can have. So for Model Q, you start with version 1, less than everything else is unaffected. And this is using a custom version type. So that's how software versions or the affected portions of whatever that's associated with the vulnerability are encoded. The format is meant to be simple and flexible so that you can it caters to a large variety of use cases. And then, but if you still have feedback, please feel free to submit to the quality working group. This is an evolving format, and we will consider any changes as that were not foreseen before. Okay, next topic is the JSON 5 schema also supports encoding scores like CVSS scores. You can have CVSS version 2 scores if you want, or version 3 or version 3.1. They're kind of similar. 3.2.0 is obsolete, but there is space to encode it if you need to. And in scheme, what it supports is that it supports multiple scores, and you can also score based on multiple product scenarios. So the scenarios are kind of flexible and they're up to you. You could consider 2 or 3 different modes of deploying your product and provide a different score for each mode. If you're running something in a server mode, your vulnerability may have a manifest. The vulnerability may manifest in a different severity versus if you are running your product as a client, it may have a different severity. So you can describe the scenario that you're scoring for and then provide a CVSS score. So at the at the minimum, you need to provide a version, vector string, a base score, and base severity that are required as part of CVSS. Most vendors provide what are called base scores, base metrics, about 8 factors that are used for calculating a CVSS base score. And this is one way that you can convey the severity of a vulnerability in the JSON record format. And if you're not using CVSS, if you have your own custom severity rating, you can also use it also encode it in the other field, declare the type of um, rating that you're using, and then provide some content with it. Now let's go to another key and required field in the CVE record entry, which is the references or links to substantiate or attest to the CVE. So these could be so these require a URL, a name, which could be used for titling the URL, and some way to classify the URL. So you can have a URL that's like a vendor advisory, or it could be an entry in a vulnerability database. It could be something related to a patch. It could be a mailing list discussion. So there are a bunch of predefined tags that could be used to classify the URLs that you're submitting with your entry. As a CNA, as a vendor, if you have provided a vendor advisory, uh, tagging it as a vendor advisory helps. When there are a bunch of URLs, it can help people to guide people to your advisory from those URLs. So this is one new feature in JSON version 5. Another feature is the CVE level tags. CVE, the entire CVE itself, the CVE record itself could be tagged, and there are some tags that have special meanings. So if the CVE is referencing a end of life product, you can tag it as unsupported when assigned, which means all products that the CVE is referring are not supported anymore, or the vetting of the CVE or the details may not have been done by the CNA completely. You can also include what's called an exclusively hosted service. That tag indicates that the CVE is for a cloud CVE. Everything, all the affected components in the CVE are cloud services. There's also a tag for disputed when there is a dispute on the CVE itself, on its applicability or of it being a vulnerability or not. Okay, and lastly and most not the least important is the CVE record also helps you uh, identify and tag people who found the vulnerability, and so you can have a list of entries um, where you can add text to thank the person who discovered the vulnerability, and also say the type of person, the type of credit that is. It could be for a reporter or an analyst or somebody who coordinated the disclosure. It could be the person who developed the fix, or the person who sponsored the work, or even tool. If a tool found a vulnerability, you could thank the tool in the credit statement. And these are also displayed on the CVE website currently. So it's a good way of thanking the people who find these vulnerabilities and help the world make a safer place. As far as resources, we have Git repo, where the CVE record format is stored as a JSON schema and maintained. Any problems or issues with the schema, please report them through the Git repo issue tracking. We have documentation available that provides the descriptions or definitions of each of the fields, and examples where available. And we have this mind map, as I showed before, that could be that could be used for navigating the structure, seeing the required fields and so on. Some of the fields have little complicated requirements. So something like versions, you have, based on what's available, the requirements kind of change. If you're providing just the version, you have to provide version and stat. Just the version, you can provide it too. But if you're providing a range, then you have to also say the type of version type. So some of these rules on the exact what's the valid record, they're all encoded in the JSON schema. And so that helps. You can use the JSON schema to validate your entries that you're producing on your end. And the JSON schema is also used by the API services to validate the submitted records. And so there's a way to make sure that the entries meet the minimum requirements or minimum structure. Okay, so that's the end of this discussion. Any questions?
Thank you, Chandan. We do have a couple of questions in the chat, but first, more generally, I was hoping that our board member, perhaps Kent, could jump in and talk about the new ADP container, current state, planned uses, the big picture. Kent, you want to jump in?
Sure, I can do that. So one of the things we've learned through the CV program is that we have a great deal of information here that's extremely valuable to the downstream vulnerability management community. It's much easier for us to capture this information as soon as possible so that it can be leveraged by the vulnerability management community, which I mentioned once before is really our ultimate stakeholders. So from the standpoint of an ADP, we consider that an authorized data publisher. That's someone who's approved by or organization approved by the program to add additional information and enrich the records that are going through. These could be, as has been mentioned, scoring systems. So if you think about potentially the exploit prediction scoring system, it's not supported today, but it could be. SSVC coming out of CMU could be. The KEV, known exploited vulnerabilities that the CISA puts out could also be classic examples of additional data that actually is valuable to link into the CVE records themselves. So the ADP is an authorized person or organizations that can update and enrich this information. Now, one of the questions that has been asked is that what if there's a ADP entry that conflicts with what the vendor has put out? We have that today. It's not anything different. It's called a disputed record. And that disputed record will, for all intent and purposes, be marked as a disputed record. So this will actually be marked inside of the JSON 5 so that you can see this is a disputed record and be able to go forward from that perspective. There's definitely going to have to be any changes to automation and tools to take advantage of the JSON 5 format, and that is, that is totally understood and will be transmitted to those vendors who actually are creating products to display and utilize CV related information. And that's really what we're looking at from the standpoint of ADPs. Now, ADPs are going to have to wait until we have a hard deploy, is my understanding at this point in time. I'm sure Chris Britton can correct me if I say something wrong here. But they are planned to be implemented as a pilot. We're going to have multiple pilots going on at the same time around ADPs to try to assure that we can sort of flush out the things that are going to be needed for us. There's also an experimental aspects, which I'm sure that will be mentioned at some point, if not yet, that would allow a CNA to experiment with adding their own specific tagging information into their records and the ADP records as well. So that's pretty much where we are. I would suspect that we're not looking at this until, as I mentioned earlier, after hard deploy, because that's when we're going to start doing the pilots. I hope that answered some questions. If it didn't, let me know.
Thanks, Kent. Appreciate that. Chandan, we do have a couple of questions. For example, unsupported when assigned. That tag, folks are asking whether it could be a version range level tag or whether it affects the whole CVE. Do you want to jump in and talk about the unsupported when assigned?
Yeah, so this tag currently is meant to be associated at the CV record level, which means when you assign this tag, it means everything that the CV is talking about is end of life products. We currently don't have a mechanism to tag unsupported versions that you're mentioning. So let's say take this example. Let's say if version 1 was unsupported, version 2 was supported. We don't have a way to say this version I'm referring is unsupported. What you could do is say if you're not fixing it, you can just mark it affected if you know. And if you're not going to evaluate version 1 at all, you could simply put a question mark and say, hey, we don't know. We don't know if this version 1 is affected or not. We're only making a statement about version 2. And you can also use the unknown to indicate everything else. So this is one way you can deal with end of life products in your CV entries. But the tag itself is meant to be used when everything the CV is talking about is end of life. There is no supported version of the product that has the vulnerability. And the purpose of the tags is that when you have 20,000 CVEs, you can filter them out at a high level. And so if you're not concerned about cloud CVs, because the cloud CVs would be addressed by the cloud CNAs themselves, or if you're not, everything that you're running in your environment is a supported version of the product, you're not bothered about end of life product, you can filter them out. So that's the reason here. If there is a CVE that affects some supported version, some not supported version, we currently don't have a clear way of marking them other than this. You can just declare them as unknown, or just say you're not going to fix it and just not provide a fix at all.
Okay. And can those tags change? In other words, if you publish a CVE with a tag, can it later be updated, made from unsupported now to supported?
Yeah, that's possible, yes.
Okay, great. Thank you. And let me just check. I think we had one other question about giving credit to folks with the new JSON 5, as Art mentioned in the chat. There are
Yeah.
minimum required fields, but there's also lots of optional fields. And so how does giving credit to a researcher or something change now with JSON 5?
Yeah, the program discourages you from putting the credits in the descriptions themselves. So do not keep the description to the description. Do not try to include everything in the description and make the description longer. So the reason it's structured is that now you have the like now you have structured fields so that you can keep this information in the record format in different parts that kind of make logical sense and not have to dump everything into the CVE description itself. And so there's a rule discouraging people from putting names and credits in the description. And so the alternate is to use the credit field that is exclusively for putting that information. But also make sure that if you are crediting somebody, make sure you have their permission to put their name and reference them. I hope that answers the question.
Okay, thank you. Do you? We've got a couple of questions about scenarios. Can the scenarios be used to state that the combination of several CVEs leads to a CVSS score of 10? Do you want to expand on scenarios?
Yeah, so this is kind of experimental at this stage. As we know, like a vulnerability, usually CVSS, if you are assigning ones, the guidance is that you kind of consider the worst possible case and provide the score. And if you take the worst possible case, but it only affects like 1% of your customer base, other 99 less severe, you don't have a way to express that. So this format kind of gives you one avenue to do that. You can describe a scenario, and you can say, well, this CVE, we used it in combination with this other CVE, this is the effective score. And so you could do that too. And so this is very flexible, but it's mainly, I would say, mainly suggested when you have very diverse set of consumer bases where you have the CVSS score is different based on different use cases of the product or different scenarios on which it's deployed. This is one way to say, if you're using this product in this way, the vulnerability manifests in this form, this severity, and express it here.
Got it. Thanks. And then back to your comment about cloud, the exclusively hosted service tag, is that for example, SaaS apps? And how is versioning handled in that situation?
So you do not have to even so the believe versioning, you could simply say star, or if you're or 0 or star to indicate you're just including everything. And if the versioning is, sometimes some of the vendors version their cloud services too, they can use that. But versioning is something entirely internal, but there's not documented at all. You can simply mention the product, um, and then consider it fixed when it has been fixed.
Roger that. I don't see, well, let's see, there's a new question in chat. Let's see if it applies. Are there any expectations regarding how different scores are handled by scanners, or will everything be critical alerts in the future?
Well, so this is again, as an experimental field. What goes into the scenario could be used by a scanner vendor to actually codify and improve the accuracy of their scan finding. So, if I say, I know, if you have enabled this feature on your product, then the score is critical. But if you have disabled this feature, then the score is kind of medium. A scanner vendor could take that scenario and improve the accuracy of their scanners, and so kind of help actually kind of bring down the number of false positives that people find in their scan reports.
Okay, great. And I see Kent has his hand up. You want to go ahead, Kent?
Yeah, I do want to mention that, with additional capabilities coming around predictive natures, as well as around different attribute scoring systems, we're going to be able to, as part of the ADP, we're going to be able to supply the downstream users, vendors, end users, the ability to depict or select which scoring system they trust the most. And if they have questions, they can try to use an attribute-based one, or they can try to use a predictive-based one. So scoring is actually going to be enabled and enhanced from the standpoint of the information we're providing, and fully expect the downstream tool vendors are going to pick up on this and add prioritization that's more focused locally instead of a base score of 6.8 or 7.0.
Excellent. Thanks a bunch. Great. I think that wraps up all the questions.